might have seen the news today that the Alzheimer's drugs donanemab and lecanemab have not been approved for use on the NHS, so let's talk about that. Firstly, let's clear up some confusion on the approval. So when drugs go through clinical trials, there's two different forms of approval they need to get. Firstly, they need to get approval that they are safe and actually work. These drugs have passed that. They've been deemed safe and effective. But they also need to get approval that it's financially worthwhile. In this case, these drugs haven't got past this point. So we're going to talk a little bit about why. Firstly, we need to know what these drugs actually do. So these are Alzheimer's disease specific drugs. They don't work on other types of dementia, which is why it's really important that we don't confuse Alzheimer's disease and dementia. And essentially the way that they work is you get an injection, an infusion of antibodies. These antibodies travel through your blood into your brain, and they target, are attracted to the plaques, amyloid plaques in your brain. Amyloid plaques are one of the first things that go wrong in Alzheimer's disease. These start forming years before symptoms, and they're just clumps of a protein called amyloid beta. These antibodies bind to those clumps, and that triggers the immune cells in our brain to go and clear those clumps away. Now, in Alzheimer's disease, we know that we have amyloid plaques, but we also have tau tangles. And amyloid plaques come first, and then later down the line, tau tangles start forming throughout the brain. And there's quite strong correlation between how bad someone's symptoms are with how much tau there is in the brain and where that tau has spread to. Whereas with amyloid, there's not that same correlation there. So these drugs work best when they are administered early on in the disease. When we see people with amyloid in the brain, but very low amounts of tau in the brain, the improvements that we see with these treatments are way, way better than people with high amounts of tau in the brain. In fact, we don't really see an improvement in these people with later stage disease. It's important to say as well, all of the other drugs and treatments that are available for Alzheimer's disease at the moment are managing symptoms. They have no effect on the disease, they're just improving symptoms. Much like if you've got a broken foot and you take some painkillers, the symptoms feel better, but you've still got a broken foot. These new treatments, donanemab and lecanemab, are the first time ever in the history of dementia research that we have treatments that actually work at slowing down the disease. The changes that are going on in the brain, they slow it down. So that's really, really exciting, but we're still a long way away from being perfect. This is just a step in the right direction. So why have they not been approved? Well, the benefits that we see in people taking these drugs have not been deemed cost effective for the NHS to be able to administer them. We would need to see stronger improvements. Also, the criteria for people allowed to take these drugs are quite strict. You need a really accurate diagnosis, and you need to know multiple things about the person before they should be allowed to take this drug. And currently, only about 1 in 50 people who go through a dementia diagnosis process actually have sufficient details to say whether they would be able to take these drugs or not. So that's one thing that's being bared in mind, I suppose, is that we actually need to get far better at diagnosing Alzheimer's disease before we can give people these drugs. So what this diagnostic process would actually entail is brain scans. These are very expensive. We need lumbar punctures, which is essentially an injection in your spine, which is very invasive. But we also need to take into account genetics. So you might have heard of a gene called ApoE. ApoE is the probably best known risk gene for Alzheimer's disease. It doesn't guarantee that you will get Alzheimer's, but depending on what version of ApoE you have, your risk changes. So there are 3 different versions or alleles of the ApoE gene. ApoE4, which increases your risk of getting Alzheimer's disease. ApoE3, which does nothing to your risk of getting Alzheimer's disease. And ApoE2, which reduces your risk of getting Alzheimer's disease. Now, what has been observed in these clinical trials so far is that people with ApoE4, one 2 copies of the ApoE4 allele, these people, while they're more likely to get Alzheimer's disease, they are actually also more likely to get negative side effects, including quite serious swelling of the brain and bleeding in the brain sometimes. So people with the ApoE4 alleles are not allowed to take these drugs, which means that if we're thinking of administering these drugs to people, they need to be genetically tested for ApoE. So there are quite a few things that need to get better before we're able to use these drugs. These drugs are still available privately, and it's incredibly expensive, and I have my own personal opinions on that. But the point is, these drugs have not been not approved because they don't work. They've been not approved because it's financially not good enough for the NHS. So what really needs to happen is we need to get better at diagnosing the diseases earlier on. These drugs will work the best the earlier on in the disease that they are given. We also need to bear in mind the way that we actually go about diagnosing: scans, genetics, lumbar punctures. As I said, only 1 in 50 people currently has enough details as to whether they could take these drugs or not. But there is still hope. There are about 30 other drugs in clinical trials at the moment, and these drugs are still being involved in clinical trials as well. So I'm going to pop an email address here on the screen for Alzheimer's Research UK, because people are still able to get onto clinical trials, especially people in early stages of disease are able to get onto clinical trials for these drugs. So not all hope is lost, but it is a bit of a blow, and we will keep pushing. I'm not involved in drug discovery, that's not my field of expertise, but as a field we will keep pushing, and we will not stop until we find a cure for various diseases that cause dementia. So thank you for sticking around. I apologise that it was a bit of a long one, but I thought that it was maybe better to go into a bit more detail. Thank you.